Example 3.2, we are given a circuit network and we are asked to find the state equation and the output equation. So as we discussed in class, you need to go through those steps. Step number 1, what do you need to do? Define the state variable. In the circuit problem, we said we're gonna use IC equals to CdVC over dt and VL equals LDIL over dt. Those are the two. So IC equals CdVC over dt. That is, what's the C value? 1 over 2 dVCT over dt. From here, we have dVC over dt equals 2 times IC of t. The second one is VL equals LDIL of dt, and we have a L as a 2, so DIL of t over dt. From here, DIL t over dt equals 1 over 2 VL of t. That's step number 1. And then step number 2, write out the matrix form. Based on our state variables, we're going to write DIL of dt and then dVC of dt over dt. That equals, we're going to have 2 by 2, and then variable is IL of t, VC of t, and then plus the input. Possibly we're going to have it, maybe not, but we need to write it I in. Now our job is find all of the numbers inside of this empty matrices, and also we are given output as y equals v naught over I naught, and that is going to be again 2 by 2 matrix times IL of t, VC of t, plus I have an I in. So we have to have the exact same order and the variable for both state equation and the output equation. Step number 3. In step number 3, we need to analyze the circuit. So what we can do, input is the current source. Easier to do nodal analysis. We're going to let this is node A and this is node B, and then assign the direction of the current. Then the first equation, I'm going to do KCL at node A, entering equals leaving. For the leaving currents, this is I sub naught, this is I sub L, this is I sub R, and this is I sub C. Then I sub in entering equals leaving I sub R plus I sub L plus I sub C. And then second KCL at node B, entering we have a IC, and also we have a dependent current source given as a 2VL equals leaving I naught. Since we have inductor and the capacitor in the third loop, we're going to do KVL in the third loop. Then we have negative VL plus VC plus V naught equals to 0. Now, for the second loop, we have 1 ohm resistor is parallel to VL. So what we can do, we can say VL equals the voltage across the inductor is the same as voltage across the first resistor. So that is 1 ohm times IR, which is IR. And then we have V naught, and V naught is 2 times I naught from here. Now we know we have dVC over dt equals to 2 times IC, and we have dIC over dt equals to 1 over 2 times VL. Step number 4, find two equations in terms of IC and VL. So once you find the expression for IC equals to something, then we're going to multiply that expression times 2, and then that's going to be the coefficient of VC right here. So we have IC and VL. From equation 1, we have IC equals I in minus IR minus IL. We don't want to have this IR, so we need to replace this IR with something else. From 4, we said IR equals to VL. If you use that, now we have IC equals I in minus VL minus IL. Then from here, we have VL. If you move it over VL plus IC equals I in minus IL. So this is VL, that's what we need. And this is IC, that's what we need, because we have IC here and VL in here. So we need to find another equation in terms of VL and IC. Then we can solve for that and fill in those blanks. So the second equation from 3, we have a negative VL plus VC plus V out equals to 0. We need VL, but we don't need this VO. We can use VC, but we don't need VO. So from 5, it says V out equals to 2I naught, then negative VL plus VC plus 2I naught equals to 0. Also, from 2, we have I naught equals IC plus 2VL. Then we have negative VL plus VC plus 2 times IC plus 2VL equals to 0. Then we have 4VL minus 1VL, so 3VL, 2IC, and that equals negative VC. Now we have two equations and two unknowns, so you can solve for VL and IC.
You can do equation 1 times
negative 2 and then add equation 2, or we can use Kramer's rule. Since there are so many variables, I like to use Kramer's rule. If we do delta, the coefficient of VL and IC. So first, from the first equation, we have a 1, 1. And then from the second equation, we have a 3 and 2. And that is 2 minus 3, which is negative 1. And then delta 1 equals the first column. We're going to write I in minus IL minus VC. And the second column is 1 and 2. And AD 2I in minus IL minus BC plus VC. And then delta 2 is we're going to keep the first column, and second column is going to be IM minus IL negative VC, and then AD minus BC, and that equals negative VC minus 3I in plus 3IC. So the first variable, we have a VL. So VL equals delta 1 over delta 1. We have a 2I in minus 2IL plus VC over, what is delta? Negative 1. So we have negative 2I in plus 2IL minus VC. Our second variable, IC, equals to delta 2 over delta 2. We have negative VC minus 3I in plus 3IC over negative 1. Therefore, we have 3I in minus 3IC plus VC. So now we have a VL and IC. What we need to do, we need to multiply IC times 2 and then VL times 1 over 2. This is what we had from the previous page. So what we can do, we want to do
2ic, and that is 6i in minus 6ic plus 2vc, and then we need to have a 1 over 2vl, that is negative I in plus IL minus 1 over 2vc.
that is going to be the coefficient of here. The dvc over dt right here equals to 2ic. So coefficient of IL, which is negative 6, coefficient of VC, which is 2, and then coefficient of IN, that is 6. And the second one is gonna go here. So the coefficient of IL gonna be 1. Coefficient of VC is gonna be negative 1 over 2. Coefficient of IN, which is negative 1. Okay, so we did the state equation. Now we need to do the output equation. For the output equation, we need to have a V naught and I naught. So let's go back and look at the equations. So from the step 3, we had these 5 different equations. Now we need to find the V naught. From 3, we have a V naught equals to VL minus VC. And then what is VL? We just found the VL here. That is our VL. We can copy those down. Then VL equals to negative 2I in plus 2IL minus VC. That's the whole thing for the VL minus VC. So the V out is now negative 2I in plus 2IL minus 2VC. That's our V naught. And from number 5, we have I naught equals to 1 over 2 V naught. So if you divide everything by 2 for V naught, we have negative I in plus IL minus VC. So now we can put this in here. So V naught in the first one. So the coefficient of IL gonna be 2, coefficient of VC negative 2, coefficient of IN negative 2, and from I naught, coefficient of IL gonna be 1, coefficient of VC negative 1, coefficient of IN negative 1. So this is our answer for state equation and the output equation.